In the traditional tokenization schemes, we were simply dividing the training corpus based on certain basic rules. But the problem with that approach is we won't be able to take into account unknown words. So how we are going to fix this problem? In order to solve this problem, we have an algorithm called byte pair encoding. Byte pair encoding is actually a subword tokenization scheme. Subword simply means we are not only taking into account a particular word, but we are also taking into account the part of that particular word. This means we are dealing at a character level, or you can say more granular level, and we are trying to create vocabulary based on those particular characters so that we can generalize over unseen words that are not appear in the training corpus. In order to understand byte pair encoding, we have to see one example so that things will become more clear. As you can see on my screen, we have this training corpus and we have word low, 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 lowest, lowest, never, 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 wider, wider, new, new. So basically I have taken this example from one of the Stanford's book on natural language processing. And in byte pair encoding, we take the vocabulary based on characters. So we are going to select all the unique characters in the vocabulary. As you can see, we also have this additional character here. So basically this is underscore. So what this means is we use this particular underscore after each word in order to show that we have one word here. So basically we are dealing with character level. So our algorithm is also considering all the characters, but we also have to implement a way in order to figure out that this is whole complete word. So what we do, we use this particular end of the word to this character here, this low. So basically whenever we are separating them together, we just add this particular character just to show that we have this one single word. The same thing we are going to do with all the words here so that we can identify that we have one particular word and it can make sense to the final output. Now we have all the vocabulary, all the unique characters, and we have this end of the character here. As you can see, this is our corpus and we have low, and we then have this end of the character, end of the word character here. And this thing is showing us how many times low is appearing. So low is appearing 1, 2, 3, 4, 5 times here in our corpus. Lowest is appearing 2 times, newer is appearing 6 times, wider is appearing 3 times, and new is appearing 2 times. You can count it and verify. And we have the vocabulary DEILNORSTW and this particular underscore. Now we are going to find the 2 characters that are appearing most frequent in the training corpus. So which are the 2 characters that are appearing most frequent in the training corpus? So as you can see, we have newer appearing 6 times and wider appearing 3 times. This means these 2 consecutive characters, these are appearing most often. That means 6 and 3, 9 times. You can verify it on your own and you will find that ER is appearing 9 times in this entire training corpus, and it is consecutive to each other, means E and R are appearing in the same manner everywhere. So 9 times. Now what we are going to do, we are going to merge them together because they are appearing consecutive to each other. So we are going to merge them together and replace them with one particular a new character called ER. So we are going to replace this with this ER, okay, in our vocabulary. So we are going to create vocabulary based on the most frequent occurrence of 2 consecutive pairs of characters. Now again, characters or subwords. So character doesn't mean like it is a subword tokenization algorithm. That means we are taking into account even the characters and subwords. So do not get confused here. Again, what we are going to do, we are going to find the next combination. So next combination is again ER and this particular underscore. So ER and this particular underscore is again appearing 6 plus 3, 9 times. So what we are going to do, we are going to add another vocabulary. We are going to combine them as ER and we are going to add this particular ER to the vocabulary. So we have added ER to the vocabulary here, and now in the next iteration what we are going to do, we are going to find the next pair that are appearing most frequent in our training corpus. So the next pair is NE. So as you can see, N and E are appearing 6 times, and N and E is here appearing again 2 times. So it's total 8 times. So what we are going to do, we are going to merge N and E together, and then we are going to add NE to the vocabulary. Okay. Now in the next iteration, what we are going to do, we are going to find the next 2 possible, possible pairs that are appearing most frequent in the training corpus. So in the next iteration, we have the term NE and W. So we are going to combine them together, and we have the term NE, new. Okay. So we have created this word new as well. So if in our test set we have this thing, we can generalize it really well. Now if you keep doing this, you'll find that in the next iteration we have LO, in the next iteration we have low, LO and W, then we are going to merge them together, we will have this low. In the next iteration you'll find that we have new and ER and this underscore combined, then these are appearing most often. Then we are going to combine them and we'll have this particular newer plus underscore. Okay. So the word newer is also taken into account using this particular algorithm. So as you can see, it is not only taking into account all the subwords, all the characters and subwords, but it's also taking into account the word. So that means we have this particular word newer here. In the same way, if you continue to do this particular iteration, you will realize that your algorithm has taken into account not only all the possible combinations of these subwords, but it is also taking into account all the words that are appearing in the particular training corpus. Now when it comes to encoding, that means when you have a test set, what we are going to do, we are going to simply apply these particular merges on our test set, and our test set will start merging all this data. Whenever it sees that ER is appearing together, E and R are appearing together, it will merge them together. So this is the simple approach that we follow in byte pair encoding. However, in practice, what we do, we try to take into account certain patterns that we want to remove. In fact, we also want to take into account spaces, because when we are working with codes and we want to feed our LLM or whatever NLP task we are working with, if you want to feed text, code, Python, or anything, then what we are going to do, we are going to complicate our algorithm a little bit using the regex patterns, etc., that I have shown in my Python code, and that's how you can simply work out with the help of byte pair encoding algorithm. So if you have any question, feel free to ask in the comment section below. I have mentioned the Python code, the Python implementation of this particular approach in the link below. You can check out the entire notebook and work out on your own.